Based on our meeting today, I just wanted to go over a few things that I've done in the past in AutoCAD, because we talked about doing structural detailing and um, how Revit and other fabrication softwares made things easier. But here's a couple things you can do if you're working at a place that's currently using Revit, or I'm sorry, AutoCAD, to make things somewhat more automated. So here's a beam that we had to detail because we were working for the steel installer, and they wanted us to provide the steel shop drawings, which normally the shop will provide their own shop drawings based on our design. But in this case, they wanted us to provide them because we were doing, it was kind of a complex system they were trying to do. I can show you the Revit file. The Revit file is where we ended up doing the Revit file later on because it was such a much easier way to control things. So basically what happened was this is a medical facility in Sacramento. I believe it was the UC Davis Medical Center. And in the operating rooms they have these booms where you would have all of your equipment. So there were these pre-manufactured plates that we had to support because all of the gas and oxygen and whatnot was going through here, and then they would attach the lights and all of the things they use in the operating room would be attached to these booms, and so they had to be pretty stout. And the other reason we had to model them is because there was quite a bit of a lot of ducts and pipes running through here, so we had to coordinate these braces going through that kind of mess of cable and ducts. So what we had done was I had modeled these beams that are connected to these angle kickers that are connected to this horizontal or vertical HSS, and they're connected to these plates. And then I had to model this magenta or pink outline is the fireproofing, and so we had to do quite a bit of work to coordinate this with the other trades. And so we initially started off like we do a lot of jobs. This job was back in 2017, I think, and we were still, some of us were resistant to getting into Revit, but I really enjoy working in Revit, so I was really pushing to get this do as many jobs as we could in Revit to kind of illustrate the benefit of it. So the way we used to do it is we would have had to do all of this in 2D, which would be really hard to coordinate in a 3D model with other trades, so we had to do it in 3D. But we ended up starting off these booms, these boom supports. They needed to add, because it was an existing building, they were modifying the building, so we had to add additional beams, these wide flange beams here. We had to add them in locations for support for the booms. And so we initially started off by our engineer would design the beams to support the loads and to add into the structure. And so we started off doing 2D drawings, and I love AutoCAD, but what I don't like about the CAD process per se is the having to not have things, if you change, like let's say I change this plate size or name, you have to change it, and every location is called out. So it takes a long time if you've got a lot of call outs. So you often try to only call out things in one location in the anticipation that it'll change. And so there's something that I use called fields. So in a text you can control F, or I believe you can right click and add a field, or in the text editor, add a field. And what a field does is it pulls data from someplace else. So you can choose the category. And here I chose the title in uppercase. And so there's a lot of different data that it can pull from the drawing itself. So here there's just job number, issue date. So all this stuff is attached to this drawing file. And so the drawing itself is as you can see up here, is 401. And so I named all of my CAD files, because they're individual sheets, the same as the piece number, so that I could copy this field around and it would automatically be named whatever my CAD file was named. And so that's just by going into the field, looking for elements that you can draw from. In this case, I recognized that I could take the title from the drawing and then name it so that I could control the data that way. So here, basically I just copied this tag around, and since all these pieces, I wanted them to be related to this 401 piece. So the plate is PL 401-1. The bolts are B 401 at each plate, and so you can rename whatever you want on here and leave the field, and it will automatically be updated. And so then if, as you're going through, you want to change the piece number, all I had to do is close out of here and change the drawing number, and it would update all my pieces. So in the beginning it was nice, so that as we're figuring out our nomenclature, because we typically don't do these kind of fabrication drawings, we do design. So all of these tags I've associated to the title, which makes it easier for later on. The other thing that I did for here is I made a table, so I've got our bill of materials, and so as you can see, there's these revision clouds clouding this. Because this is an existing building, we had our client was out there on the site, and he was taking dimensions and really getting us tying down where all these locations were. So as we're getting updated information, I can stretch the length of these beams and adjust the coping. There's actually in the steel catalogs, in the steel, there's actually specific way that you're supposed to cope these, and the bolt hole locations and all these things. There's a specific way you're supposed to do them. But as I'm modifying it, I can use fields in this table So see here, I connected the title there. And so as let's say I saved out as this drawing, saved that as a new name, all of these would be updated to 402, 403. And so you can also use fields for entities too. So here I have this plate. I wanted that dimension to change if I ever had to change it. And so it's set to an object and measurement. So see how I've set the object type to rotated dimension? So basically what you do is you'd go and you'd pick the dimension you want it to copy, or to monitor basically. Choose the dimension, and then we want, let's see, what was it set to? Measurement. It gives you a preview of what it's going to show. And then now in our table, if I were to update this width of this plate, it will update the width if you regenerate your sheet to the width that I just changed. So now it's a plate, a 3/8 inch plate by 5 7/16, because that's what I stretched it to. So if I were to undo, it changes back. And so I did that with all these other links. So if in the course of events I stretched this beam, which I did, it automatically updated the lengths. And so that's just one way in AutoCAD to somewhat automate some of your dimensions. And then with these fields, there's lots of possibilities. So I could add a field, just hit Control F here, select any object. Let's see, an object that we want to select. Let's just do this title block. And so if I wanted it to read the A from the detail number, the distance would be part of this. This is a dynamic block, and there's probably a distance length for this line, which is probably 3'10" and 5/15/16, because we do our drawings to a scale. We don't do them actual size. So there's lots of different information you could draw just by selecting an object, picking that object, and then finding what data is related to that object that it could be useful to you. You do the unit factor, the scale, lots of different things here. So fields are a good way to a good thing to utilize. And you can see even in our title block, we have fields that draw data from an external text file that is created when we create our projects, which we can thank your customizing AutoCAD teacher for all of these little features here. I'll just do a little shout out to Phil because he created this AutoRefs, which is a referencing system similar to Sheetset but 10 times better, that he developed and made. So it makes our lives much easier so that we can do callouts that automatically update, similar to Revit. So that is a huge thing for us. And so as we progressed in the project and we saw the complexity was continuing to build, and we needed to have more of detail, we needed to have these beams, we actually decided to go the route of using Revit, and which made our lives and my life much easier, because having to detail all these things out in CAD, especially as I'm adjusting. So as pipes are going through here, let's see if they've got well, I won't bring up the coordination model because it's a big model, and we'll just hold off for that now. So in Revit, instead of doing all the fancy CAD work with the fields and having to kind of do things manually in 2D, we use Revit to create the same kind of system, but everything in Revit, because it's a building information model, which all these entities that I've created have information that is connected to them. And so I was able to create all of these shop drawings from Revit. So let's look at one of those boom supports, because I don't know, it was pretty fun doing them. So all these are modeled in Revit, and the interesting part in here is because they had to fireproof these beams and there was a lot of issues that they had, all of this stuff had to fit together. So they were going to drill these holes, and then this angle was going to have to be able to hit the holes on here, because they wanted to weld this thing in the shop, lift it into place, and have everything in the correct location. So, and actually these angles are welded to this this beam, but it looks like we did a bolt connection at the top. I'm trying to remember all the stuff we did because it seems like such a long time ago now, but you can see I was able to model. Actually, I created this family, this boom family. This is something that you'll have to do manually sometimes to create boom or create different things from Revit families, so that you can get all the information you need. And so in this boom, we have the data. See, I have this L601 over here in the identity data, so that we can tag these. So if I go to tag, just like when we were tagging a wall in class, you can automatically have the information there because it's stored within this element. It's stored within this beam, and then it makes creating all this shop drawings much easier. So these, and this is another thing to note as well. We are not a steel detailer, so we're not you know, we don't really prepare drawings for a fabricator. So in this project, I created these. These would be more like assembly drawings. This is how this all goes together. And here are all the different parts and pieces. As you can see, I had to adjust some of these to avoid different elements that were in the model, like piping and ducts. So you can see I had to kind of, they're going to have to weld this plate at an angle. Actually, it's already built, so they've already welded this plate kind of at an angle, but they wanted to do this all in the shop, so they didn't have to do any of this welding and stuff in the field, which can be a pain, especially on a remodel. And so I added all the parts and pieces for that previous sheet to this sheet. And the interesting thing about this is that for any of you guys who've worked in a shop, this is not how a typical shop or steel detailer would detail their sheet. You would usually have one piece on one sheet, and so you would have this L601-3. It would be on a sheet by itself. It would have its bill of materials, and all these would be different. So when we sent these to our client, who was the installer, he then provided them to his shop, and so their shop came back and, you know, was like, hey, you know, typically we have one piece for one sheet, because you're going to give this piece, this little plate, you would give it to one guy, and he's going to go out and make that plate. And if he has to make, let's see, number 8, 601-2, so 601-2, there's 3 pieces, so he'll make 3 of those plates. And here's the information for the plate, the length, and any other comments, and the material grade. And all that information, the nice thing about these Revit schedules is we add the information into this plate, and you can look at the properties of it, and all this information is here. So no matter where we use this plate, it will have that information. So let's say I use the same plate on a different boom. I can give it a different name that's associated to that boom, or that boom support. So it would be a PL602-2, and it's the same plate, but we're using it on a different piece. So but it's nice to not have to redo that over and over again, because you've done it once. You copy this plate around, you need 3 of them, and it just makes your life a ton easier by doing in Revit. And from what I understand, steel fabricators, there's good software that I think that they use that is not AutoCAD or Revit, but they have their own steel fabrication software. But anyway, that was just a short video kind of showing little Revit tips to kind of like, or a little CAD tip to somewhat, automate your CAD drawing, so that it does have some data that's automatically filled in, and you don't have to worry about back checking your drawings to make sure that your dimensions match, because this isn't a live piece. This is just line work that we produced with an add-in that has all your steel shapes. So we use Steelworks, and I believe we have the Al's steel. I'm pretty sure we have the Al's Steelwork, but that doesn't matter. That's neither here nor there. And then the way you're also able to utilize this kind of automated system in Revit to much greater accuracy and proficiency. So that's pretty much it. I just wanted to share that with you guys, since I was talking with another guy at the end of the meeting about some of this stuff. So hopefully it helps, and let me know if you have any comments or questions, additional questions. Thank you.